Dear students, today we are going to see Cauchy's integral formula. So Cauchy's integral formula, there is another form of Cauchy's integral formula such that we can use that formula to find the given curve. Okay, so we have two formulas. What we have discussed earlier, that is one formula. Now we are going to see another formula for the Cauchy's integral formula. Okay, so what is that form? That we'll see. That is 1 by 2 pi I into gamma f of z by z minus a dz is equal to 2 pi I f of a into n of gamma comma a. This is another important formula where we can make use of this formula to find the given curve and the solution. Okay, so here now what we have done in the previous formula is we have not taken n of gamma comma a, but we have taken n of gamma comma here. This is nothing but index of a point on the closed curve. This is the index of the point on the closed curve, such that we make use of this point and we will try to find out the solutions of given problem. Now first of all we will try to do the problems by using of this formula. Okay, the first problem. The problem is compute integral mod z is equal to 1 e power z by z dz. So he will be giving the question in the form of like this. So integral mod z is equal to 1. This is the closed curve which is given, and e power z by z is z, and e power z by z and dz. Now what is that? We'll see. Okay, what is given? Given f of z is equal to some e power z, and here a is nothing but 0, because mod z minus a is 0, here also z minus a is 0. Okay, so therefore what we can write here is f of a. I may write the value of f of a. I should find out the value. F of a means nothing but 0. F of 0 is nothing but e power 0, means f of 0 like e power 0. F of 0 e power 0 in the place of z is a. Okay, e power 0, that may be equal to 1. Now this is what we have. Now we need to find out n of gamma comma a. Now what is n of gamma comma a? N of gamma comma is nothing but n of gamma comma 0. Now what is the value of this actually in general? Now we should draw the diagram. Let us take, this is mod z is equal to 1. So with the help of the radius 1, we have drawn the circle. Okay, with the radius 1 we have drawn the circle. Let us take the circle with the radius 1. Now this is nothing but 1. Okay, with the radius 1. So z minus a is nothing but 0. So 0 is inside of the circle. 0 is inside of the circles. So therefore n of gamma comma 0, whenever the point which is there inside of the circle, will make it as 1. We'll take that value as 1. If suppose any of the value which is in outside of the point of this circle, means this closed curve gamma is nothing but 0. So inside means we'll take 1. How you got 1? That we'll see the theorem. So that we'll understand. So this is 1. Now what is the answer now we are going to get? Now we'll substitute all those values. Integral mod z is equal to 1 e power z by z dz is equal to, we'll try to write like this formula. This is 1 by 2 pi I integral over gamma. Gamma means mod z is equal to 1. Now f of z by z minus 0 dz means f of z is nothing but this. So I may write as e power z here. So that is nothing but equal to 2 pi I. So 2 pi I into f of a means f of 0, that is f of 0 into n of gamma comma 0. Okay, now 2 pi I into this is 1 as well as this is 1. The answer is nothing but 2 pi I. You got as 2 pi I. Still n of gamma comma 0 1 also we can able to find. We can find n of gamma comma 0 as 1 with the help of the index formula. So that also we'll try to find out. Okay, that we'll do in the form of like this. Okay, now we'll try to find out n of gamma comma 0. We just found the n of gamma comma 0 as 1 with the help of one theorem. With that we got from here. Now what about n of gamma comma 0? Okay, n of gamma comma 0. Now n of gamma comma 0 is equal to, we have 2 pi I into gamma dz by z minus 0. This is the formula. The formula is n of gamma comma a is equal to 1 by 2 pi I integral gamma dz by z minus a. Now this is the formula. Okay, so instead of finding directly, instead of finding like this, we can find directly, but still we can find this one. Okay, this is dz by z minus 0. So mod z is nothing but equal to 1. Okay, so z is nothing but equal to, I may take as e power it, where theta is nothing but belongs to 0 comma 2 pi. Okay, now we'll try to find out the value. This is 1 by 2 pi I integral 0 to 2 pi. Now dz. Now if at all I wanted to have dz, I may write dz is equal to I into e power I theta into d theta. So I may substitute here I into e power I theta d theta by z is nothing but e power I theta. 0 is nothing but anyhow, that is 0. So therefore you will be getting as e power I theta. So this e power I theta, d power I theta gets cancelled. So you will be getting as 1 by 2 pi I integral 0 to 2 pi I into d theta. You got like this. So therefore when you got that one, then what you have to do? This is 1 by 2 pi I. Okay, I will take it out. Integral 0 to 2 pi d theta. So this is 1 by 2 pi I into I into theta, that is 0 to 2 pi. 1 by 2 pi I into I into again 2 pi. 2 pi minus 0 is 2 pi. So these two gets cancelled. You get as 1. So you can find in the manner of like this also of n of gamma comma 0 like this. But what the theorem says is, according to theorem, what are the value which are there inside the region of gamma, then that value will take it as 1. So therefore you can do in this manner, or you can directly take 1 according to the theorem. So, okay, so we'll try to solve one more problem based on this method. Okay, now we'll do one more problem. The problem is compute integral mod z is equal to 2 dz by z square plus 1. Now he has given mod z is equal to z square plus 1. Solution. I'll just write the formula first. Formula is integral gamma f of z by z minus a dz is equal to 2 pi I into f of a into n of gamma comma a. If you don't write intervals, nothing will happen. Or you can write f of a into n of gamma comma a. I am using this formula. Okay, this formula I am using. Okay, so before that, this one. This is z square plus 1 is there. So we'll try to write the z square plus 1 in the form of like this. So z square plus 1 I wanted to write this entire part in the form of some z minus a form, or z plus a or z minus a, but it should be like z minus a only. You have to remember that it will be always should be like a z minus a form. Okay, so this one I can write as some z minus I into z plus I. It is like z minus I into z plus I. So I may write this as integral mod z is equal to dz by, this is z minus I into z plus I. Okay, now this is z minus I into z plus I. Now I wanted to do like a partial fractions. This is the method where we can get two integrals by using the partial fractions. So by using partial fractions, what we'll do now? This is 1 by, I am finding out this value, z minus I into z plus I is equal to a by z minus I plus b by z plus I. This is 1 is equal to a into z plus I plus b into z minus I. So put z is equal to I. So this will get cancelled. You will be getting as 1 is equal to I into a. So that implies a is equal to 1 by 2i. Similarly, if you put z is equal to minus I in this value will go, this will be there. So you will be getting as 1 is equal to minus b minus 2ib. So you will be getting as b is equal to minus 1 by 2i. You got as b as minus 1 by 2i. So I may write this as like this, 1 by z minus I z plus I is equal to a value is 1 by 2i. So I may take 1 by 2i into 1 by z minus I plus b value is minus 1 by 2i. So I may write here minus 1 by 2i. I may write this as 1 by z plus I. Now this value I got. So therefore what I'll do is, I'll just take integral on both sides. Integral on both sides if I take, what is going to happen? Now integral of gamma dz by z plus I into z minus I is equal to. Now I am taking integral on both sides. I have taken integral to the left side and this one. So I'll take 2i common. Otherwise 2i you keep it like that only. Into gamma dz by z minus I. This is the first one. Minus 1 by 2i outside I have kept. Into gamma dz by z plus I. Now this is what we got. Now this is again in the form of like f of z by z minus a form. Now we'll try to find out what is that mod z is equal to 2. So we'll try to draw the circle with radius 2. The circle with radius 2. Okay. Let us take, this is 2, minus 2, 2, 2. This is minus 2 and the 2. Okay. X axis and y axis. Clear? Now z minus I means a value is I. Now where that I lies inside the circle or outside the circle, that we should find out. So I may write here as mod z equal to 2. Here as mod z equal to 2. This is a closed curve. Mod z equal to is a closed curve. Now what about the I? You can say that on the imaginary axis this is nothing but 2i. I 0 minus I minus 2i like that. Okay, so I will be, you can see positive one. So it is inside the region. So it is inside the region. Okay, so therefore what is the value of that n of gamma comma I? So I may write this one in the form of like this, 1 by 2i first into f of a. F of a is nothing but I know. So f of I into n of gamma comma I minus 1 by 2i for this also into I should write 2 pi I, no? So this is 2 pi I according to the formula. 1 by 2i is this, 1 by 2i according to formula 2 pi I into f of a into n of gamma comma a. So f of a is nothing but I, n of gamma comma I minus 1 by 2i into 2 pi I into f of minus I okay, into n of gamma comma minus I. Okay, n of gamma comma minus I. So n of gamma comma I is inside. So therefore what I'll write, I will cancel 2 I gets cancelled. This is pi into f of I. Here f of z by z minus I means f of z is nothing but 1. So f of I is again 1. N of gamma comma I. Gamma comma is, because I is inside, that value is 1. Minus 1 by 2I. Now this is f of minus I. Where is the minus I? Minus I is also inside. N of gamma comma minus I is also inside. So this value is 1. F of minus I is again 1. So these two gets cancelled. I gets cancelled. You will be getting as pi into f of minus 1 is again 1. N of gamma comma minus I, because it is inside the region, that is nothing but 1. So this is pi minus pi, that is nothing but 0. This is a way to find out the solution of integral over mod z is equal to dz by z plus a, z plus and z minus I, like this. So only thing that you have to remember is whichever the value which are there inside the region, that will take it as 1. And f of a is nothing but which is there in the f of z value, that we are going to see. So this is the one of the problem. Now we will try to do one more problem so that we will understand it clearly. So the problem is in the form of like this. The problem is like this. Integral gamma, that is nothing but gamma is nothing but mod z is equal to 3. Now e power z by z minus 3 dz. I will write the formula once again. Integral gamma f of z by z minus a dz is equal to 2 pi I into f of a into n of gamma comma a. And this is what the formula, I am using the formula that. Okay, now we will try to find out this one. Now what is gamma? Gamma is nothing but mod z is equal to 3. So solution integral over mod z is equal to 3 e power z by z minus 3 dz. This is given. Now we will write whatever the value it is given. F of z is given as e power z. F of z is e power z. Then f of a means what? 3. F of 3 is equal to, now this is e power z, so this is e power 3. Okay, now we should find out n of gamma comma a. Gamma comma a means again 3. So let us draw that circle. Now this is a circle which is nothing but, the radius is nothing but 3 minus 3 and the 3. Okay, now mod z equal to 3, but a is 3. So understand, a is also 3. A is 3 means it will be on the value, means it will be inside only, inside or on. So therefore n of gamma comma 3 is also 1. So that's what is the value now? So integral mod z is equal to 3 e power z by z minus 3 dz is equal to, according to formula, 2 pi I into f of 1 f of a means 3 into n of gamma comma a is nothing but again 3. This is 3. This is 2 pi I into f of 3 means e power 3. N of gamma comma 3 is nothing but 1. So what is the answer? So 2 pi I into e power 3. This is the answer. 2 pi I into e power 3 is the answer. Now this is the way to do the problem of this type. Okay, so you can make use of this formula, or in our unit we are not going to take n of gamma comma a. So that will be understood by taking the values of the problem according to the theorem. Now we will go for the another important problems like this. We will try to find out the other important problems if that is the case. Now we will do one more problem, like integral c cos z by z into z square plus a 8 dz. Now this is another set of problem where instead of taking n of gamma comma a, I am not taking n of gamma comma a. Means I am taking rise like this into gamma f of z by z minus a dz. I will write here as z naught is equal to 2 pi I into f of z naught. Now I am using this formula. I am using this formula. I am not taking n of gamma comma a. Means n of gamma comma a is nothing but understood. Understood whether the point is inside, will take it as n of gamma comma, that point is 1. If it is outside, it is 0. Now we will try to find out these values first. But what is C? C is given as mod z is equal to, it is obviously, it is given in the form of like this. It is given as a square such that x is equal to plus or minus 2, y is equal to plus or minus 2. It is given in the form of like this, plus or minus 2 and y is plus or minus 2. Means it is nothing but the point here is minus 2, plus 2, and this is minus 2 and the plus 2. Now this is the region which is given. It is under this region. Okay. Now we will try to find out roots of z into z square plus 8. To find the roots, it should be equated to 0. So therefore I may write this as is equal to 0. You should get the roots by equating the 0. So I may get z is equal to 0 and z square plus 8 is equal to 0. So z square is equal to minus 8. Z is equal to minus 8 root 8. So therefore I may write this as 2 root 2i plus or minus 2 root 2 I got, and z equal to 0. You should understand 0 is in here, 0 is in the middle, mean the center. So from these roots, now what are roots you got? Z equal to 0 you got, z equal to plus 2 root 2 I you got, and z is equal to minus 2 root 2 I you got. But we'll take what is the actual. So if I write mod z equal to plus or minus 2 root 2 I mod, you will be getting as 2 root 2, which is greater than 2. You will be getting as always greater than 2 because root 2 is 1.732. If you multiply root 2 is it's not 1.732. It is okay. If you multiply 2 into the root 2 value, you will be getting always greater than 2 itself. So therefore these 2 points will lie outside of the region. It will lie outside of the region. Okay. So therefore these 2 points does not lie in the region. Only z is equal to 0 will lie in the region. Okay. So therefore what you have to do? How you are going to do this problem? By using that formula without n of gamma comma. You should understand n of gamma comma 0 is 1 here again. If n of gamma comma 0 is 1. So instead of taking this one a partial fractions again. So we are not going to take a partial fractions. In the previous method we have taken partial fractions. No, that we are not going to take. Now how you are going to do? We will take in the form of like this. Integral c cos z is equal to cos z by z into z square plus 8 dz. This I may write in the form of like this. Integral c. I may write this as cos z by z square plus 8 by z into dz. I have taken this z square plus a to the numerator. Means this becomes as a f of z. So understand, this becomes as a f of z because z square plus 8, these two are not in the region. So that I am taking as a f of z. So therefore now you apply that formula. What you are going to have? This is 2 pi I into f of z naught. F of z naught means this is f of z. So f of z naught is nothing but 0. This here is z minus 0. So f of z naught is f of 0. F of 0. This is f of 0. But what is f of 0? Means this value. Means I may write this as 2 pi I into cos 0 by 0 plus 8. I am just writing cos 0 by 0 plus 8 because f of z is nothing but equal to cos z by z square plus 8. Okay, so f of 0 means cos 0, 0 plus 8. Cos 0 is 1. So you will be getting as 2 pi I into 1 by 8. So therefore what is the answer you will get? You will get pi I by 4. You got as pi I by 4. So you must understand one thing, that the two roots which are not lying must be taken into the numerator, that becomes as f of z, and whichever the point lies inside the region, that you have to take it as in the denominator, so that you will get an answer in the form of like this. This is another way of doing the problem. So one more problem we will try to do so that you will understand very clearly. Okay, so by this method of one more problem, the problem is in the form of like this. Okay, same c is same. Okay, integral c z by 2z plus 1 dz, where c is nothing but x is plus or minus 2, y is nothing but plus or minus 2. This is 2, minus 2, minus 2 and the 2. Okay, now you should understand, now I wanted to change this one. So z, I should write in the form of some z minus z naught. It should have only z. You must see that there should not be any coefficient of z. Only z should be there. But here coefficient is 2z is given. So what I will do is I will take 2 common. Z plus 1 by 2 I am writing, and the dz. Still I can write in the form of like this, c. I may write z by 2, I will write z. This 2 I am taking to the numerator. I can take that 2 outside also. That also is fine. Okay. So, but instead of taking that, I am taking to the numerator. And z plus 1 by 2 dz. Now z is equal to what? The roots of the denominator, that is z plus by 2 equal to 0. This is what are roots? Z is equal to minus 1 by 2. So minus 1 by 2 means minus 0.5. So that is there inside the region. Here somewhere here, that will be in the region. So therefore what I will do is integral c z by 2 by z minus of minus 1 by 2 dz is equal to, okay, 2 pi I into, now here f of z is nothing but z by 2. Now I have taken f of z as z by 2. So f of z means minus 1 by 2. So f of minus 1 by 2. This is 2 pi I into f of minus 1 by 2 means this one. So I may write as minus 1 by 4. Z is minus 1 by 2. The 2 will go to denominator. Denominator. So therefore minus 1 by 4. You will be getting as 2 1s, 2 2s. Minus pi I by 2. Now this is the way to do the problem. Just simply you can do. Or if I take 2 outside, then what is going to happen? 1 by 2 integral z by z plus 1 by 2 dz. Okay, so if that is the case, what is the answer? Now 1 by 2 into 2 pi I into f of minus 1 by 2. Okay, this is 1 by 2 into 2 pi I into z value is, f of z is z only. So this becomes minus 1 by 2 again. Okay, so these two gets cancelled. You will be getting as minus pi I by 2. So if you can take outside of that integral also, you have got the same thing. If you take numerator also, you got the same thing. So like this you can do the problem. Now we will try to do one more problem so that you will understand more clearly of this type with the same c, that is same closed curve, like integral c cos hz by z power 4 dz. Okay, this value will make use of that value with the help of, okay, this is again the higher order derivative. So we'll go for the theorem such that by using that theorem we'll do the higher order derivative. So before going to the higher order derivative, we'll try to find out one simple theorem such that you'll get an idea about that. Okay. So these are the two different ways of doing the problem of Cauchy's integral formula. One is n of gamma comma a. The other one is without n of gamma comma a, how to use that one by taking the numerator, whichever the point which is not lying inside will be taken that point to the numerator and make it as a f of z, and we can draw that we can get the answer from that side. Now we'll do one theorem which is to solve the problem which is having a higher order, means extension of the Cauchy's integral formula we are going to do. We are going to find out the extension of Cauchy's integral formula. So what is that extension? We'll try to find out now. Okay, the theorem will do a small theorem. The theorem to find like this: if a function f of z is analytic in a region D, f of z is analytic in a region D, then its derivative at any point, z equal to a of D is also analytic in D, and is given by, okay, that is f dash of a is equal to 1 by 2 pi I integral over c f of z by z minus a whole square dz. Okay, this is what we are going to find, where c is any closed contour, in D surrounding the point A, that is z is equal to a. Now this is one of the result which we are going to use to solve the actual formula of Cauchy's integral formula for the derivatives. One result we are finding. Now how we got this one, that we'll make use of this point in the next theorem, which is very, very important. Okay, proof. The proof is nothing but we'll take h. Let us take a plus h be the point. We'll take the point a plus h in the neighborhood of the of the point A. Now we'll take the a plus h in the neighborhood of the point A. Then by Cauchy's integral formula, Cauchy's integral formula which we have, now what we have, that Cauchy integral, that I'll write with the help of, that is f of a is equal to 1 by 2 pi I integral c f of z by z minus a into dz. This is what Cauchy's integral formula. So now I will take in the place of a as a plus h. So this I'll take equation 1, and I write as this as a plus h in the place of a by using the Cauchy integral formula only. This is 1 by 2 pi I integral c f of z by, this is in the place of a plus h. So z minus a minus h, minus if you multiply that become like that. dz is nothing but equation number 2. Now we'll take these two. So I may write a plus h minus f of a. So you'll be getting as 1 by 2 pi I integral c f of z by some z minus a minus h dz minus 1 by 2 pi I integral c f of z by z minus a dz. I am taking both these two equations and subtracting. So if you subtract, what you are going to have, instead of to find the required result, we are just subtracting like this. F of a plus h minus f of a is equal to 1 by 2 pi, 1 by 2 pi you can take common, as well as f of z also you can take common. So I will take 1 by 2 pi common, integral of c 1 by z minus a minus h minus 1 by z minus a into f of z dz. This is 1 by 2 pi I. Integral c, take LCM, z minus a minus h, z minus a. So you will be getting as z minus a minus z plus a plus h. Okay, by taking LCM into f of z dz. Now this is what we got. So z and z gets cancelled, a gets cancelled. So we will be getting as 1 by 2 pi I integral c h by z minus a minus h into z minus a into f of z dz. Now this is what we got after simplification. This h I'll take to this side. So that becomes a plus h minus f of a by h is equal to 1 by 2 pi I integral c f of z by z minus minus h into z minus a dz. Now you got in the form of like this. Then, so the h I have taken to this side. Now I will take limit. Limit h tends to 0. F of a plus h minus f of a by h is equal to limit h tends to 0 1 by 2 pi I integral c f of z by z minus a minus h z minus a dz. Now this is the term which I got. So this I may write as f dash of a. This is the derivative. Total f dash of a is equal to h tends to 0. This h tends to 0. So 1 by 2 pi I integral c f of z by, this is z minus a into z minus a you will get, because h is 0, and you will be getting as dz. Now this becomes f dash of a is equal to 1 by 2 pi I integral c f of z by z minus a whole square dz. So therefore what we got is f dash of a is equal to 1 by 2 pi I integral c f of z by z minus a whole square dz. Now this is the result we are going to use to find out f power n. F power n we are going to find out, means f power n will be getting as n factorial by 2 pi I integral c f of z by z minus a whole power n plus 1. So for that theorem we are going to use this value. So this is the one of the result. Then we will try to prove that Cauchy's integral formula for higher order derivatives. Now what is the higher order derivative, that we will find. Okay, so Cauchy's integral for derivatives. Cauchy's integral for derivatives. We will try to find out this theorem. So we will try to write the statement. Suppose f is analytic. F is analytic inside and on C. F is analytic inside on C or on a simple closed contour C. Instead of writing only C, I am writing as contour C. Contour C. Let Z not be a point. Z not be a point interior to C. Then f power n of z is equal to n factorial by 2 pi I integral C f of s. I am taking here s minus z whole power n plus 1 ds. Instead of taking, I have taken z here, instead of a I have taken z, so I have changed that in the form of s. Okay, where n is nothing but equal to 0, 1, 2, 3 and so on. You take it as this as equation number 1 instead. For any z which is belongs to D and C is positively oriented. C is positively oriented. C is positively oriented. Now this is what we have to prove. So you must remember that if n is equal to 0, you will be getting, or n equal to 1 if you take, n equal to 1, f power n means f dash of z, 1 factor means 1 by 2 pi I, s minus z to the power 2 means you will be getting what we have proved just now. So that will write. So note that for n equal to 1 it will be got like that. If n equal to 0 you will be getting Cauchy's integral formula. If I put n equal to 0, so if I put n equal to 0, what you are going to suppose to have, n equal to 0 means this is nothing but 0, the derivative power f power 0 of z, 0 factor is 1, s minus z whole power 1 and f of z. So you will be getting as Cauchy's integral formula you will be getting as leads to a Cauchy's integral formula as a special case of that. Okay, so therefore this 1 is an extension of that. Let us draw one diagram so that you will understand very clearly. Okay, let us take the diagram in the form of like this. Okay, the point I will take here z, and this is nothing but D, and this is nothing but the point S. I mean a little bit I will extend here. This is z plus delta z. Okay, this is z plus delta z. From here to here is delta z. So what I have taken, this is nothing but C. C is a closed curve. The point S and D are the points which are there on the closed curve. The point Z is nothing but in the curve here, closed curve, and from here to here is nothing but z plus delta z, and this is nothing but the value D. So you remember this one, and we'll try to prove after this. We'll try to write the things now. What are the things we are going to make use of the value? Okay, so making use of this, we'll try to prove the Cauchy's integral for higher order derivative. Okay, so first of all we'll write the things. What is that one? Now we'll write Cauchy's integral formula. We'll write first Cauchy's integral formula. The Cauchy's integral formula is f of z is equal to 1 by 2 pi I integral c f of s minus z ds. Okay, this is number 2 because already we have taken number 1. Now this is number 2. Okay, where z is the interior to C and s denotes the point on C. I may write this diagram over here with a small notations, means with small diagram you can understand d, z, and this is z plus delta. This is delta z, what we have chosen. This is x axis and this is y axis. So where s and the d are the points on the C. Okay, so now f dash of z I will write. What is f dash of z? 2 pi I integral c f of s by s minus z whole square ds. Already we have done this in the previous theorem. We have proved that this is what we have. Okay, then let us denote that d is the distance between, the smallest distance. Otherwise I may write d denotes the smallest distance from where? From z to the point S. The point S is on the C. Now this is a circle C. Okay, small point S on C. Now with the help of equation 2 I may write like this: f of z plus delta z is equal to, I am writing as f of z plus delta z is equal to 1 by 2 pi I integral c f of z by s minus the value of z is z plus delta, so z minus of z delta z dz. Now this is the value which I got. So making use of these two, I'll subtract these two by taking those two. So this you take it as number 4. What we have done in the previous theorem, the same thing we are going to do in this also. So from 2 and 3, what you are going to have? F of z plus delta z minus f of z is equal to, this is 1 by 2 pi I integral c f of z by s minus z minus delta z dz minus 1 by 2 pi integral c f of z by s minus z dz. This value also I have taken. So f of z plus delta z minus f of z is equal to, I will take common 1 by 2 pi I integral c I will take common, and f of z also I can take common. So I may write 1 by s minus z minus delta z minus 1 by s minus z into f of, this is f of s, not z, this is f of s. Here also this is s. Okay, f of s, and this is ds. F of s ds. This is also ds. Okay, so this is also ds. Right. So if you can able to calculate that, you will be getting in the form of like this. So therefore f of z plus delta z minus f of z is equal to 1 by 2 pi I integral c, taking LCM of these two. This is s minus z minus delta z, s minus z. Now s minus z is there, so I will write s minus z minus s plus z plus delta z by taking LCM into f of s and the ds. Okay, f of s and the ds. This total is for that. Okay, this is 1 by 2 pi I. Okay, integral c. So this s gets cancelled, z gets cancelled, you will be getting as delta z by s minus z minus delta z into s minus z into f of s ds. You got this value. So taking the delta z to the left side, so what is going to happen? If you take to the left side in the denominator, so f of z plus delta z minus f of z by delta z, I have taken the delta z to the left side. So what you got? 2 pi I integral c f of s by s minus z minus delta z into s minus z ds. You got in the form of like this. So what I'll do is, I'll subtract equation 2, equation 3 on both sides. Now what is that now? F of z plus delta z minus f of z by delta z minus 1 by 2 pi I integral c f of s by s minus z whole square ds. And just subtracting on both sides this one. This is what from where we got from equation 3 we got f dash of s. That I am subtracting on both sides. 1 by 2 pi I integral c f of s by s minus z minus delta z into s minus z minus 1 by 2 pi I integral c f of s by s minus z whole square ds. Okay, I have subtracted on both sides. So f of z plus delta z minus f of z by delta z minus 1 by 2 pi I integral c f of s minus z whole square dz is equal to, here you can take 1 by 2 pi common, as well as f of s also can be taken common. So 1 by 2 pi I integral c 1 by s minus z minus delta z into s minus z minus 1 by s minus z whole square into f of s ds. Have taken that one. So what is the remaining term which we got from this? So that we'll write here. So left side f of z plus delta z minus f of z by delta z minus 1 by 2 pi I integral c f of s, this one, s minus z whole square dz is equal to 1 by 2 pi I integral c. Now if you take LCM, so LCM is s minus z minus delta z into s minus z whole square. That is the LCM. Okay, so you will be getting here only s minus z minus, again you will be getting here s minus z is there, or s minus z whole square is there, so you will be getting as s plus z plus delta z into f of s ds. So therefore you will be getting as 1 by 2 pi, you will be getting as 1 by 2 pi integral c, s gets cancelled, z gets cancelled, you will be getting as delta z into f of s by s minus z minus delta z into s minus z whole square ds. You got in the form of like this. Then, so what shall we do now? So we'll take mod on both sides. We'll take mod f of z plus delta z minus f of z by delta z minus 1 by 2 pi I integral c f of s by s minus z whole square ds. This is not dz, this is ds. ds into mod 1 by 2 pi integral c delta z f of s by s minus delta z minus delta z into s minus z whole square ds. Now we'll try to find out this mod z, mod f of s, and those all values of this. So what we'll do now? We'll try to write all such values by with the help of the formula which we have here. So let us take m. M is nothing but, I may write as mod f of s is less than or equal to m. M is nothing but a positive value. Okay, and the maximum value is m. This is the maximum value. M is the maximum value which it is bounded. And I may write s minus z. S minus z. S minus z is, you can understand, this is always greater than d, greater than or equal to d, and mod z is less than or equal to d. Now this value from here to here is always less than d. Okay, we'll try to find out. S minus delta z is equal to, I may write s minus z minus delta z. I may write this as greater than or equal to mod s minus z minus mod delta z. This I may write it as s minus z is nothing greater than or equal to d, so this is d minus, and mod delta z. Okay, I may write this as d minus mod delta z. I may write this as d minus mod z. Mod z is less than or equal to d. I may take it as some d by 2. So you will be getting as some d by 2. You will get the value of this whole thing. You got as some d by 2. So we'll make use of those all values and we'll try to substitute in the previous value. So you'll be getting in the form of like this: f of z plus delta z minus f of z by delta z minus 1 by 2 pi I integral c f of s by s minus z whole square ds whole square less than or equal to 1 by 2 pi. If you take mod I is 1. So integral, this is mod z mod f of s. Okay, then mod s minus z minus delta z mod s minus z whole square mod ds. Everything is mod. So 1 by 2 pi into, okay, mod, this is nothing but m. I may take m outside, m. I may write mod delta z, I'll write here itself, and I don't want to change mod delta by s minus z minus delta z, I may write as d by 2 into s minus z whole square. S minus z whole square is nothing but it is less than is greater than equal to d, so I may write as this is d square integral c mod ds. Okay, so what is that now? Mod ds is nothing but length of the curve or length of the closed curve less than or equal to, I may write as 1 by 2 pi mod delta z into m by d by 2 into d square. This I will write L, where L is equal to length of the curve. See, L I have written. Okay, so letting delta z tends to 0. Now what is going to happen? Letting delta z tends to 0 means limit delta z tends to 0, f of z plus delta z minus f of z by delta z minus 1 by 2 pi I integral c f of s by s minus z whole square ds. This is everything is 0. So that is nothing but equal to 0 because mod delta z nothing but equal to 0. So what you will get now? So therefore you will be getting as limit delta z tends to 0. This is I may write as f of z plus delta z minus f of z by delta z is equal to 1 by 2 pi I integral c f of s by s minus z whole square ds. This everything is again f dash of z is equal to 1 by 2 pi I integral c f of s by s minus z whole square ds. Now what I got here is the thing which I got here is again f dash of z is nothing but you got the same thing. This proves that the theorem may be proved for the next value also. If you take the next value, that is if I write like this, if I suppose write like this for n equal to 1, if you write, it is true for n equal to 1. N equal to 1 we got the same thing. If you take n equal to 1 you got the same thing. If you write like this, f dash of z plus delta z minus f dash of z by delta z minus 2 factorial by 2 pi I integral c f of s by s minus z whole square whole cube n equal to 1 if you take, so you will be getting as whole cube ds tends to 0 as delta z tends to 0. Then this will be what? This will be f double dash of z is equal to, you will be getting as 2 factorial by 2 pi I integral c f of s minus z whole cube ds. For n equal to 1 if you take, if you can continue that one, you will be getting as f double dash. In the similar fashion, you will be getting as f power n of z is equal to n factorial by 2 pi I integral c f of s by s minus z whole power n plus 1 ds. So what you got here is, this is the only the value, the theorem what we wanted to prove. So f power n, this one s minus z whole power n plus 1. Now we will be getting as f power 0 of z is nothing but obviously equal to f of z for n equal to, because since 0 factor is nothing but 1, so you will be getting as f for this also will be true for this, and this also can be written in the form of, integral c f of z by s minus z whole power n plus 1. I may write as z minus z naught whole power n plus 1 dz is equal to 2 pi I. I'll just take to this side, 2 pi I by n factor into f power n of z naught. I may write like this, here n equal to 0, 1, 2, 3 and so on. So this is the way to get the Cauchy's integral for the derivatives. You may use this formula or you may use this formula to find out the problem for given the derivatives. Which type of problem you are going to consider? Let us take cos hz by z power 4 dz. You should understand here it is given z power 4. So it is something like n plus 1 form. So whenever it is given some n plus form, or you can take z square also, like n plus form. There we are going to use this formula to get the solution. So this is called the Cauchy's integral for the derivatives. Thank you.